In the last unit, we were introduced to the idea of functions in general and linear functions in particular. In this unit, we're going to continue to focus on linear functions and trying to understand how they work and also understand more about their graphs. Now, we're going to introduce a particular characteristic of a graph of, well, any function, but linear functions as well, that is called the intercept. In a graph, an intercept is a point where a function crosses an axis. An intercept on the x-axis is, unsurprisingly, called an x-intercept. And an intercept on the y-axis is called a y-intercept. So let's look at some examples to make sure we understand what an intercept is. So first example, we have a graph and we're asked to state the intercepts of the graph. So where are those intercepts going to be? Well, the intercept on the x-axis is right here, and the intercept on the y-axis is right here. In fact, let's actually label them. So we have our x-intercept, which is right here, and we have the y-intercept, which is right here. Now the question asks us to actually state what they are, and the way we're going to state those are with coordinates. So the x-intercept, it has the coordinates 6, 0. And the y-intercept has the coordinates 0, -2. Let's look at the intercepts for another function, but this time we're not actually given the graph, we're given the rule. So if we have a rule, we can use that to find our table. And we've done this many times before, but we take our input, substitute it into the rule. So for this first entry, it'll be 2 times -5 is -10. Negative means it's positive. 10 divided by 5 is 2, plus 4 is 6. We can go through and do this for the rest of the entries in the table, and we get those outputs. You might want to double check that those are correct. Now that we have our table, we can plot the graph. So first point will be -5, 6. So let's just double check I'm getting this right. That will be right there. A little bit off the grid line, but let's fix that up. Next one is 0, 4. So that will be there. The next will be 5, 2. Then we have 10, 0. And then we have 15, -2. So, now that we have those points, we can go ahead and plot our graph. Remembering that we like to put arrows on the end because this function doesn't stop just because we've reached the end of the graph, but keeps going in both directions. Now our intercepts are our points where we cross the x and y axis. Now, limitations of trying to rule a line by hand means it's not necessarily going to be exactly in the perfect place, but we know where it should be. Our x-intercept goes through the point that we actually plotted here. That was at 10, 0. And then the y-intercept it has the coordinates 0, 4. Now, taking a look at our answers for both of these questions, hopefully there's one thing that stands out to you. For every single one of our intercepts, one of the coordinates was 0. In fact, it's the other coordinate from the coordinate that matches the intercept we're finding. So for our x-intercept, x was equal to 6, but y was equal to 0. For our y-intercept, y was equal to -2, but x was equal to 0. And in our second example, we got a similar result. So x was 10 for the x-intercept, but y was 0. Y was 4 for the y-intercept, but x was 0. Now, if you stop and think about why this is, well, it really just comes about because intercepts are on the axes. Our x and y axis are going to be the lines where the other coordinate equals 0. So the intercepts have to have that same property. What this means is that x-intercepts occur when y is equal to 0, and y-intercepts occur when x is equal to 0. So any intercept occurs when the other coordinate is 0. What this means is we can actually find the intercepts for a function without even being able to see what the graph is. So we have the function y equals 2/3 of x plus 8. To find the x-intercept, and I can just abbreviate that as x-int if we want to, we are going to take our function. So we have 2/3 of x plus 8. Now we know this happens when y is equal to 0. So that means the rule needs to produce an output of 0. Well, this gives us an equation to solve. So if we subtract 8 from both sides, let's actually get some training wheels happening here. So subtract 8. From that, we get that 2/3 of x is equal to -8. Now remember, what we're doing is dividing by 2/3, but we can achieve that by multiplying by 3/2, multiplying by the reciprocal. Which means that x is equal to, let's see, -8 times 3 is -24, divided by 2 is -12. So we get that. For the y-intercept, we're going to find this using x equals 0. So y is equal to 2/3 of x, but we know x is 0, plus 8. Now, 2/3 of 0 is 0, so this is simply 0 plus 8, which is just 8. So that's all the information we need to write down our x and y intercepts. The x-intercept is going to be at x-coordinate -12 and y-coordinate 0. And the y-intercept is going to have a x-coordinate of 0 and a y-coordinate of 8.